Good morning everyone. In this particular video lecture, we are going to discuss the relation between line voltage and current to phase voltage and current in a star connection. In the previous video, we have discussed regarding the star connection and delta connection. Now as you can see here, this is the star connection. Now as you can see here, this one is the R phase, this one is the Y phase and this one is B phase. And my dear friends, here we have denoted the phase voltage and line voltage. As we know, the voltage between line to line is known as line voltage, and the voltage between one line and neutral is known as phase voltage. So here as you can see here, the voltage between the line R and the line Y is denoted by here VVR, and similarly the voltage between the line R and the line Y is denoted by here, as you can see, VRY, and similarly the voltage between Y and B is denoted by VYB. And now all these are, that is VBR, BRY and VYB, all these three are, my dear friends, line voltage. And if you want to denote the phase voltage, then this one is the neutral and this one is the R phase. So here VR is denoting the phase voltage, and similarly here VY is denoting the phase voltage through, we can say, Y terminal, and this one is the VV. And now my dear friends, all this VR, VY and VV is known as phase voltage, because all these three voltages are measured here in between line and neutral. So all these three are phase voltage. Now as you can see here, the line voltage VRY is the vector difference of VR and VY, or the vector sum of VR and VY. Now as you can see here in this figure, there are basically three line to line voltage. The first one is VRY, the second one is VVR, and the third one is VYB. Now as you can see here, VRY is basically the vector sum, or we can say the vector difference of the voltage between the R terminal, that is VR, and my dear friends, VY. And similarly VVR means the voltage between the V and R phase, which basically we can say, my dear friends, VV minus VR as a vector difference. Similarly as you can see here, VRY is denoted by VR minus VY. And now we will draw the phasor diagram. As you can see here, this one is VR, this one is VY, and this one is VB. And now my dear friends, as we know, VVR is equal to, my dear friends, here we have denoted VRY, and as we know, VRY will be equal to VR and minus VY. So my dear friends, this one is VY, and if you want to take negative of it, then we have to proceed it in the opposite direction, and that's why this one will be VY minus of VY, as you can see here, and this one is VR. And so my dear friends, this will be the resultant, and this is denoted by VRY, as you can see here. And now as you can see here, our parallelogram will be formed here. And now my dear friends, as you can see here, this angle will be equal to 60 degree, and it will basically be divided into two parts by this diagonal, or we can say as a equivalent voltage VRY into 30 and 30 degree, as you can see here. So this is basically the phasor diagram. And now with the help of this phasor diagram, we will, my dear friends, calculate some we can say we will derive some formula. As you can see here, from this if we apply the parallelogram rule, then we can write VRY is equal to root under VR square plus VY square plus 2 VR VY into cos 60 degree, because the angle between VR and VY is here, my dear friends, as you can see here, 60 degree. And as we calculate this, then our equation will become something like this, as you can see here, 2V phase square plus 2V phase square into 1 by 2. And my dear friends, this will be equal to root under 3 V phase square. And from here, as you can see here, VRY will be equal to root under 3 V phase. And as we know, my dear friends, this is line voltage, and here we can say line voltage is equal to root under 3 into phase voltage. From this derivation we can say it easily. And now my dear friends, as we know, this one is the phase voltage, this one is also the phase voltage, and both this one is the phase voltage. So we can say that line voltage is equal to root under 3 into phase voltage in case of, my dear friends, a star connection. And similarly we can derive by using the y and b phase and b and r phase, and our equation will be equal to root under 3 v phase and root under 3 v phase. So my dear friends, VRY, VYB and VBR is equal to line voltage, as we have already seen in the diagram. And now in a star connection we can finally say that the line voltage is equal to root under 3 into phase voltage, my dear friends. And if we want to talk regarding the phase current, as you can see here in this diagram, that this one is IR, the current flowing through the, we can say, line R, and this one is IY, as you can see here, IY, and the current flowing through the B terminal is IB. And my dear friends, all these are IR is equal to IY is equal to IB is equal to phase current, we can say here. And in general, my dear friends, in delta connection, IL means line current is equal to phase current, my dear friends. And now as you can see here, for any balanced star connection, the current flowing through all the three phases and its summation will be equal to 0, as you can see here. Line voltage magnitude is root 3 times the phase voltage magnitude, my dear friends. As you can see here, as we already have derived that IL is equal to I phase, means line current is equal to phase current in case of a star connection, and the, we can say, line voltage, that is VL is equal to root under 3 V phase in case of, my dear friends, a star connection, and the current in line and phase are same. So my dear friends, this was all about the relation between we can say the line voltage and current to phase voltage and current in case of a star connection. That is for the video, my dear friends. I hope you have enjoyed this video. That's all. Thank you.